Good afternoon and welcome to another Micrographics webinar. Uh, Today's webinar will be focusing on Fusion 360 nesting. This is a preview design function, or should I say a preview function. It will be added to the nesting and fabrication extensions once it has reached its full sort of potential. So what we're seeing here is preview functionality, which at a later stage seems that it will become part of the paid extensions. I'm your presenter, Carl van Rooyen. I'm an application engineer at Micrographics. If you do have any questions relating to the webinar, we are going to have a Q&A towards the end of the webinar, but you can also get hold of me at my email address here on the first slide. And we can then answer your questions as needed. So moving on to today's agenda, we are going to be starting off with a intro to nesting. So for those who may be new to nesting and just need a little bit more information and to be brought up to speed on what nesting is, we'll have an intro into nesting. Then we'll talk about some modeling best practices when it comes to nesting inside of Fusion 360. So we will be taking a close look at kind of the model and what you can expect to see at this time in Fusion 360. We'll then look at the process material library. This is where you'll actually add your stock material into the library to be able to nest onto. We'll create a nest study and look at the settings for creating that study. And then we will review the results of a nest. We'll then close off with a summary and a question and answers session. If you do have a question that comes up during the course of the webinar, you're more than welcome to put that into the chat. You should have chat control panels or chat panel at the bottom. Should I say chat controls at the bottom that you can enable the chat and then send a message through. So let's move on to an intro into nesting. What is nesting? It's got a little picture on the right there of a bird with a nest on the back of a duck. This is not the type of nesting we'll be talking about today. The type of nesting we're talking about is the processing step between what the designers do to create the design in CAD and how it will actually get manufactured on the factory floor. Between the design and manufacture, there needs to be some processing done where a person or a department who is dedicated to this task will take these parts and place them down on a sheet of material for cutting. So they'll take the flat patterns of all the components that fit the specific requirements, and they'll place them down onto that sheet for cutting. If parts are bent or not flat, they'll unfold these models and place them onto a flat pattern, or the flat pattern would be used, and these flat patterns are organized on a sheet of material like a jigsaw puzzle. To basically try to fit as many of them onto the sheet as possible. So let's have a look there. There is a actual nesting as far as manufacturing goes. We have a sheet of material with parts being cut out of that sheet, and we can see how tightly packed those parts are. So by doing this, it in turn optimizes the use of the sheet stock that you are using and reduces the amount of wasted material between the components. There may be certain criteria for organizing the parts, such as grain direction. So if you're dealing with a brushed material, that brush direction would be very important. For those who work with wood, you would have the wood grain that needs to be considered as well, whether it be an engineered melamine or a solid wood. That grain direction would be important. And also when nesting, you need to take into account single-faced materials, and these considerations will be discussed later on in the in the webinar when we start looking at nesting settings. So the goal of the nesting is basically to organize your parts onto a sheet, optimizing the use of that material, and therefore reducing the amount of the wasted material between the parts. The end goal here is basically to save you money once all those components are cut. So why is it important? As we said in the previous slide, it reduces, by nesting automatically inside of a program like Fusion or any more advanced nesting programs, it reduces the time to manually nest. You don't have to have an operator sitting manually trying to play Tetris with all the pieces and position them onto a sheet and use the most of the sheet. And by doing this, reducing the time to manually nest and doing it in an automated process, that then also reduces the wastage. By reducing the wastage, you reduce your component's overall cost. Less wastage means you have to charge less for the components. And at the end of the nesting, you'll be able to get a report that will also calculate the material cost per component, calculate the overall material cost. So if you're doing a big job, you can get to your overall material cost a lot easier. And you can also pull reports on material usage. So there'll be a lot of information that you can actually extract out of the nest once you have completed it and you're viewing your results. And we'll see that towards the end of the webinar with the results section. So this is important. You can see there on the right-hand side, money's involved. Even Madiba is happy there that we'll be saving time and money using nesting. So what are the typical types of parts to be nested? Now that we know what nesting actually is and why we'd want to do it, we need to know what type of parts would typically be nested. And this is actually quite an easy question to answer. We can basically say any part that is made from flat stock or sheets can be nested with other parts of the same material spec. So this would mean that the material type and thickness match. Many components can be made from flat stock, whether it is steel, plastic, cardboard, or even leather. We can consider various types of materials. And here we have a few examples on the slide of display stands made from plastic and cardboard, as well as some sheet metal components, which could be part of a much larger machine. And if there were multiples of these sheet metal components, we would want to be able to nest them onto the same material sheets. So all of these items would have started out as flat stock and been cut and bent into shape. And in sort of one of the most extreme cases, we can look into shipbuilding. You can see in the picture here, there are a lot of shapes and sheets, and this would have all been nested into steel plates and cut out before assembled and welded together. I suppose your ships nowadays are your world's largest jigsaw puzzles. So I'm going to do a very quick demo to kind of show some of the concepts that I've spoken about already when we talk about a component and its flat pattern, talking about unfolding a part to show its flat pattern. And then I'll have a look, move into the nesting environment, and we can look at the nested result. I'm talking about fitting things onto a sheet like Tetris or a jigsaw puzzle. We'll have a look at that and physically see what it looks like inside of Fusion. And basically doing this in the hopes that it'll help you understand the process as we're talking through it in the rest of the webinar. So here I have a very simple cabinet. It's made out of sheet steel. The doors are, if I remember correctly, 0.7 millimeter steel. The rest of the structure is 2 millimeters. But if I go and pick a component, let's just say the top door here, I can activate that top door component. Let's just have a zoom in here and see. We can see it has the large flat face with flanges bent back around all four sides. So this door has a flat pattern, so I can go and activate that flat pattern. Because I used the sheet metal commands in Fusion 360 to create it, we can quite easily flatten that out and then view that component. I see my Fusion is taking a few seconds here just to update, and there we have the flat pattern showing for that component. And that's what would be placed down onto a much larger sheet. That's quite a simple component. We can go to one of the side uprights. This one here actually has a cutout in it. Let's go to the flat pattern for this one. And we can see the flat pattern here for that component, with the turquoise lines or cyan lines being the bender lines where that part needs to be bent. So most of the components in my assembly that I have here are sheet metal components. Just activate the main assembly. You can see here that they all have the sheet metal icon. I do have two other components which I put in here as tests. One of them was a side panel. Just move the view here. Initially, it looks like a sheet metal part, but in the corner there are no fillets, so this is not a part that would open up and create a flat pattern. And I also have a revolved base, kind of looks like the bottom of a umbrella stand. And this was just a test as well, and we'll see what happens with these in the later on in the webinar. So that is the cabinet that I want to now nest and place all of those components down onto the flat sheets. So if we go into the manufacturing environment, I have already pre-done the nest, so I have these results showing. But towards the end, we will also end up updating the nest to view some more information. So let me just activate a sheet here with some more parts on. So here we have a nested sheet with a couple of the components on. So it looks like it's three larger doors and then 4 of the smaller doors on this one sheet. So that is what we would term our nested parts. And so, when we're talking about a nest study, that would be this entire result set down the left-hand side, but this would be a single sheet that's nested. So hopefully that will just give us a little bit of a better understanding as we go further into the webinar on some of the words and terms that are used. So now that we know kind of what nesting is, we need to look at what can we nest. So being a preview at this stage, there are no requirements for a component to actually be included in the nesting study. So it could be a sheet metal part, as we saw in my design, mostly sheet metal components. However, there are still some, however, it still brings in standard components as well. So it will consider all of the components essentially within your assembly. So whether it's sheet metal or standard. However, there are still some best practices that would be helpful to follow. And I've broken down these best practices into 2 sections. The one would be the best practices for sheet metal, and then the second section is best practices for standard components. So on the slide here, we're looking at the modeling best practices for sheet metal or SM components. And this would basically align with your standard sheet metal design best practices, and it does help going forwards with nesting as well. So if you have designed using the sheet metal components, then you need to consider the following. The material has to be of a uniform thickness, with no area in the design that is thicker or thinner than the specified sheet metal thickness. So you would have a sheet metal rule that says it's made from 2mm steel. Your design has to have that uniform 2mm thickness throughout. The folded component or the flat pattern itself also cannot intersect itself, as this would make it impossible to open out or to open up and create that flat pattern. So the example on the right here, we have those two flanges that bend back inwards to the middle of the part. If those flanges were too long and they touched in the center, or even worse, overlapped in the center, it would be impossible to open up that part to create the flat pattern. And then one of Fusion 360's limits is that you are limited to creating a single-bodied sheet metal component. So each component in my design that is a sheet metal component only has a single body. And the nesting process also only considers the first body in a component. So when you create the nest study, it finds the very first body in that component, and that is the body that is used for nesting. Then the last sort of requirement is that the part has to have a flat pattern. If you do not pre-generate the flat pattern for that sheet metal component, the nesting environment will consider it the complete folded model. And so essentially it will first look for a flat pattern. If it doesn't find a flat pattern, it will use the folded model and nest the folded model. So you want to go ahead with the sheet metal parts and make sure that you have a updated flat pattern available for it. And then the last point here is that you can do the nesting with a single component. Maybe you just need to do a run of a single part, but you need to cut out 100 of them. You could do a single component and nest 100 of those onto a sheet, or it could be a complete assembly. In the case that I have with the cabinet, it's a complete assembly, and that entire assembly will be nested onto the various sheets. Moving on to the modeling best practices for standard components. As mentioned earlier, the first body in a component is used when nesting. So if you have a standard part that you do want to nest, you then need to make sure that the geometry that you want to nest and at the end of the day cut out of your stock is the first body in that list of bodies in that part or component. All the other bodies are ignored when it comes to finding the length and the width of the component and adjusting for the spacing and also for the perimeter. We'll actually see in the results that we can have the perimeter of the part projected onto a sketch as well. So first body is used, all the others are ignored, and the thinnest dimension of the bounding box for the part is used for the material thickness. So if we look at those stands that I've got there, the 4 components there, when the nesting process runs through and it finds that body, it finds the smallest dimension of the bounding box, and that is what's used for the material thickness. That part was around about, I think, close on 200 millimeters tall. And so once again, this could be a component or an assembly, and it would then take all of those parts, components, and create the nest for that. Now you might kind of ask yourself, well, how is this useful? The parts that I have shown there wouldn't really work very well in a nest and to be cut on a, let's say, like a laser or plasma cutter. But if you're into cabinetry and you are working in the cabinetry industry or in an industry where you are doing, let's say, 3-axis machining on large flat boards, then this is actually quite useful because you can have, and in this case, the image on the right, it shows doors for a kitchen cabinet being nested onto what we would call a nesting router. And so they're nested to make use of the optimization of the board itself. But over and above that, the geometry is brought in where you can still then do your machining for, in this case, all the grooves to make the grooves and the bevels in the door to give the patterns on the doors. So you don't have to think about just cutting out the profile or the outer shape of a component, you can still go that extra step, especially if you have something like these nesting routers, where you can use that to cut out the outer profile as well as add any detail on top of the stock as well. So that there would conclude kind of the best practices for both using sheet metal components as well as standard design components. With that being said and that covered, you do need to be careful when creating a nest where you have things like hinges and handles and nuts and bolts and screws. You would need to exclude those from the nesting study, and we will actually, I will show how that is done when we go through the nesting study setup. So just want to go back into Fusion and just show you that example here of those solids that were nested. We can see here that those 4 components are nested onto a sheet. That sheet thickness matches the height of the part. And if I flip this over, we can see the perimeter of the part is projected into the model as well. I can go in here and actually switch off the visibility of the components themselves, and we can see the profile of each of those components shown. Now you might see these big round discs highlighting as well, just to show you what happens with the multiple bodies. I actually designed this component with 2 bodies, and we'll see the body 1 is the visible body that is brought into the nest. If I switch the visibility of that body off and then switch body 2 on, I had created these big donuts basically, just as a test to see if it would bring that in, and it only brings in that first body. So just reiterating on what happens there with your standard components when they are brought into a nest. Now, the next section that we'll move on to is going to look at the process material library. And what is the process material library? Well, we have an idea of the parts that we want to create, but we need to know what material we have on hand. So we have the process material library, which is the place where we will actually load up what materials we have or keep in stock. And so you would go to your stores, you would get out a list of all of the materials that you generally stock and use within your process, and you would go into the process material library and add those into the library. This library is split into 2 separate sections. One is materials and the other is packaging. The material would be specifying the actual material as well as the thickness and some certain properties relating to that material. The packaging is how you actually receive the material. So you first create your available materials. I've got there steel, aluminium, etc. Then once you've created your materials, for each material, you would then create your packaging. And the packaging there in inverted commas refers to, are you receiving it in sheet form? Do you receive it in coil? And what is the length and width of the sheet or the coil that you receive? At this point, you can also put in extra properties such as trim value. That's essentially how close the part can be to the side of the stock. So depending on the accuracy of your process, if you're throwing that down on the laser cutter and your operator is not spending too much time setting it square, you might add a bigger trim value there. You can also add cost. So in your material and packaging library is where you add your cost for your material as well. I must admit, in my example, I've left the cost as 1. So it's 1 unit per sheet. And so we'll see all the costs come through as basically almost like a percentage of the sheet size itself as a cost. So if you used 50% of the sheet, the cost would be 0.5. But you can adjust, you can put in the actual rand value of the sheet. So we've got the option there of sheet or coil. So just, go through to there, and then just to take a deeper look into the material library, I have a couple of slides which go through some of the options that we have, and then I'll go into Fusion and we'll see what it looks like inside of Fusion. So the material section, like I said, it's split into two. The material section allows you to put in the material ID. In this case, we'll see there on the left-hand side, those material IDs were created automatically for me, but you can actually create your own IDs and your own names. So there we've got steel dash 2 millimeters, and working your way across the table to the right, you're able to choose the actual material type, the thickness, categorize it. So whether you work with, let's say, ferrous and non-ferrous, or even wood, you'd be able to choose a category to categorize it. There is also a density value. And once you create the nesting, a nesting color to also be able to, in the reports, have the materials colorized. There are more settings across to the right from this that I have not shown in the screenshot, but we will have a look at them inside of Fusion. Now, just to stick with the materials here for a second, every time you create a design, that material library is blank. So Fusion the Fusion developers have a mechanism where you can create a preset material list. And we can see here at the top, there is a add option, an add from preset and sync from presets. So we can actually either add a single line material and type in the values, or we can add from preset and choose a preset. So my suggestion with this going forwards, if this is something that you integrate into your workflows, is that you create a blank part, a blank component or design in Fusion, and you populate the material library, the process materials. If I skip over to the next page here, we can see these presets in the fabrication tab of the manufacturing workspace, where you would typically manage your post libraries, your tool libraries. There is a section there for material and packaging presets. And this actually allows you to then add all of the material and packaging in the current design to a preset. It takes all of them in. So right up front, I would suggest you create a blank design, put in everything that you need or that you stock, and then create a preset. You could also break the presets down. It could be steel only presets. It could be a preset for aluminium only, or preset for wood. And so you can have that preset, and every time you then take a design and nest it, you can load the preset into your material library. Just makes life a lot quicker and easier when working. You don't have to manually go and add in all those line items again and all the settings. So just a little tip there on the presets. So for us just to see what that looks like here in Fusion, we'll go, I'm here in the manufacturing workspace, and on the fabrication tab, we have the options for the process material library. Select that library and it will then open up the library. Down the left-hand side here, I have my materials, so steel 2 millimeters, steel 0.7, stainless steel 2, and so on. And for each of those materials, I have packaging. And so we can see the various, in this case, I have 3 different packages. The first one would be a standard sheet size. The second one is an oversized sheet. And the third one, in my case, I was putting it in here with the idea of, okay, I have a leftover piece from another job. So that would have been a remnant from another job. So I've put that in there so that that can be used. You'll see the comment there, offcut. So that can actually be considered and used when creating the next nesting study. And so it can work away at that, it can work away at the offcuts. For the actual material itself, if I click on steel, we have our general settings. This is what we saw in the PowerPoint. We can go to the packaging tab, and this will then show the list of packaging as we have on the left. And on the nesting tab, this will set up the nest settings for the material itself. I mentioned earlier about grain direction and single-sided materials. We can see here that for positioning, we have the option to put in a material grain, and we also have the option to choose whether the material is single-sided or double-sided. And that will also control whether or not parts can be flipped to fit on the sheet. So that would be important to keep in mind. We have other orientation options. Are you allowed to rotate components on the sheet by a set angle? So this would just control how the algorithm rotates and moves and turns that component to fit into the sheet. You know, like your Tetris. Tetris, you can only rotate to 90, 180, and 270 degrees, and your original 0 degrees. Here we have a deviation option, though, where we can actually set that we can deviate from that 90 degrees by up to 40 degrees in increments of 10. So we can go from 0 to 10, 20, 30, 40 degrees. Once it hits 40 degrees, it would have to jump to 90 or go over 90. So there's quite a bit of overlap here with that set as is. And you would go through each of your packages and set up the packaging. We can see here, if I click on a package itself, we can set the length and width and the form here, where I spoke about rectangular or roll, or coil, as I was calling it earlier. And there is the cost value as well. If we go to nesting, we have the trim value that I spoke about. How close to the edge of that actual material are you going to have your parts positioned? So that is your material and packaging library. All of those properties are basically listed within the tables or as you select those properties. If we go to manage, you're able to go to material and packaging presets, and selecting the add option will allow you to name a preset, and it automatically pulls through all of those materials and packagings in the active document into that preset. One thing I skipped here is I can say add from preset, and then choosing the preset would allow you to choose which material you want to add from that preset. Okay, so once you have set up your materials, you're then able to go over and choose your component sources. It's time to sort of create or start creating that nesting study. So back into the presentation here, I'm going to have a look at creating the nest study. And the first thing to do is look at the component sources. This is what files are you actually going to pull into the nesting study and then place down onto your sheet metal or your sheet material. So selecting the component sources icon in Fusion will give you a list of all the components available for nesting. We can see on the right hand side, I've actually scrolled across in that screenshot so we don't see the part name, but you would have the part name and then the related properties. And on the far right hand side, we can actually see a preview of the actual component. So this component source will show the properties applied to each component, what is the material being used, and what are the material and packaging properties relevant to that material. And this also gives the opportunity to adjust settings per component. It actually allows you to deselect the option called bind. And once you've deselected bind, you're able to then change things like the rotation and deviation for a specific component. So you can actually fine tune how each component is treated in the nest study itself. You can also change priority while I'm here and seeing this. There's a priority option you can also set. So the higher the number, 100 being the max, the higher priority the part gets for cutting. So if you have a high priority job and then a slightly lower priority job, you can actually change the value so that the high priority job gets nested first, and then after all of those components for that high priority have been nested, the lower priority files are then nested afterwards. And so that's adjustable between 0 and 100. So once you have selected your source components and deselected the components you don't want to nest, once you've selected your source components and changed the properties, if you need to, you would then create the nest study. Now, the nest study has multiple tabs for the various settings for the nest. And so what the nest study allows you to do is go through and each tab and break down the settings and set what you need. So I'll go through here with the study tab first. These are kind of like your general nesting settings. You can put in comments about the nest. The most important thing here to really look at is the job quantity. There's an option there for single value shown in the top picture, or the bottom picture shows a multi-value. And the single value would allow you to say, okay, from my source components, I want to create 4 of those assemblies. So in this case, I have a cabinet. I actually have a large cabinet and a small cabinet. It'll create 4 of each. In the picture at the bottom, setting multi-value allows the user then to take the multiple sources and say, okay, there's a small control box. We want 1 small control box, but we want 4 control box V7s. So that's the larger control box. So it'll nest 4 of the larger control box and 1 of the smaller one. So you can actually adjust the values of the assemblies being nested, or the components being nested there. Moving on to the next tab, shape, that allows you to view all of the actual files that are going to be nested and then deselect files that you do not want to nest. Now, earlier on I said that pretty much all components are considered for nesting, and it's at this stage here that you would want to remove components that should not be nested. One thing that you can do is look at the thickness. I see there's a part thickness there, 24, and one that's 187. So those are components that should not be nested. It could be, now my names aren't really great, component 21, component 22. It could be a hinge, it could be a handle, nuts, bolts, screws, things like that. You would go through and remove from the list so that you do not have them nested onto materials with completely arbitrary thicknesses. And so that's the main reason for the shape tab. There's a lot of properties that you can view in this panel. You can go through this to review the properties for each of those components. The next tab is packaging. In a nutshell, this allows you to choose the available packages, so the available sheets that are needed. So at the bottom, we have the inventory. That's everything that is available listed at the bottom. And then at the top, those would be the actual packages used in the study. So you could take out let's say the oversized sheets and put in your standard sized sheets into the study, and it'll only use the standard sized sheets. If you had offcuts, You can put the offcuts in there as well. And you can also choose to use the priority in which those packages are used when the nesting is actually calculated. Global parameters allows you basically to just position the parts in the nest and set up the nesting calculation settings. So you've got your nesting settings there for the entire nest itself. And on the output tab, that controls what the study will actually create as an output. In my case, I left it all on. We created the manufacturing model, created the part outlines. We looked at that earlier with the circles around those stands that I had. And then another option is to include the stock. So my model actually has the stock box as well. This is nice from the output perspective if you're using Fusion 360 to generate your CAM process, because you can take the manufacturing model with the stock and convert that directly into a CAM setup to be able to then set your stock, your models, and your toolpaths. Okay, so just back into Fusion to breeze through that in real time in Fusion. We had the component source option, which would bring up the component source dialog box. I'm going to just make this a bit bigger so we can see some more information in here. On the left-hand side, we have all the part names and the related information for those parts. So we can see all the information required there, all the quantities required, and the priorities. Below this list, if I minimize that, is the list of the actual flat patterns in that assembly. That's for the small control box. Then for the large control box, we have all the parts listed there as well. So what I did here was I actually created the nest study and then used the add option to then browse to another file and load another file in. So you can actually load multiple designs into one nesting study. And that allows you to run multiple jobs, multiple assemblies at one time. Selecting a part here will give you the options on the right-hand side for the settings to adjust settings. With component sources selected, you're able to go to the Create Nesting option. In this case, I'm going to say single value, and I want to create 2 of them. And this will do 2 of each of those cabinets. And for the source objects, I can see here there's those 2 files. I want to exclude those. And I'll basically go through the list and select what is required. One thing I didn't mention about the packaging is you can set your inventory quantity. So if I look at the available sizes here, I have a 3x2 meter size. Maybe I want to use that and get rid of it because I only have one of those in stock. So I'll double click on that and add that in. And so I have it here. I'm just going to click the little arrow to move it right to the top. And I've got one of those in stock, so I'll add that to 1. And I'm going to choose from a packaging use method as listed. So it'll start at the top and use that sheet first and nest on top of that sheet. And I can work that out of inventory. So you can play around nicely with this to control what stock is being used to generate the specific project. Okay, I won't go through global parameters and outputs, but once you hit OK, that will then generate the nested study. Now, I have 2 studies already here, so it's going to create a 3rd study. And we can see in the browser on the left-hand side, it starts to generate nested nodes. Nest 63, 64, 65, and 66 basically represent the different material types being used. And for each material type, there is then a sheet output for each material. So you can see for 64, I've used 2 sheets of material there. And Fusion is just busy calculating and generating the nested result. So I'll just give that a second to do that. While it does that, unfortunately, Fusion is somewhat locked, so I won't be able to browse through anything here. But what I'll do is I'll return back to PowerPoint, and we can see, as I noted, the nodes in the browser on the left are created for each material type. So then each nest number there, and then it lists the sheets used for each one. How many sheets, and if you select the sheet, what is on that sheet. In the outputs, what you're actually able to do is you are able to compare sheets with each other. So you are able to select one sheet or multiple sheets and compare and view the information regarding that sheet. And you can also then generate a report from the results, and the report would show you how many sheets were used, what your part cost is, and parts that may have been excluded, might not have fitted onto a sheet. And so that report would have that information and more. Let me go back to Fusion, and we see here, this is my first sheet. This looks like it was that large 2x3 meter sheet that I had put first in the list. And so Nest 63, if I right click on that sheet and choose the compare option, that will load information, basically a mini report for that sheet. And in this report here, we can see the efficiency, so 44% of the sheet being used. And we can then view also the sheet size in the image on the right hand side. So we have that 3 meter by 2 meter sheet, and it shows you the used length and the remnant length as well. As I mentioned with the costs, I left the costs at 1. So the total nested cost here is just over half the cost of the sheet, and the cost of the remnant is the balance of that. So we get the cost values here as well. Now, if I go ahead and grab Nest 64, by selecting on Nest 64, we're able to also right-click and compare, and you would get a comparison and a report on both of the sheets used in Nest 64. So we can see what the usage is here as well. We get all the same information, in this case with the entire nest. So we're looking at the efficiency across both sheets. To jump between the sheets, you can use the activate icon to then activate the next sheet to view each sheet. If I go to Nest 65, I can activate that, and I can see here there's only two pieces on this sheet. I just want to quickly check settings on that sheet. This was, for some reason, 2 of my components were stainless steel, where the rest were standard steel. So hence why these 2 are on that one sheet. So that would be our stainless. And we have these last 2 on this sheet here as well. So you're able to view your nesting results within Fusion physically to see the layout itself, and using the right-click compare option. For the entire study, you can, or for a nest itself, let me actually go here, Nest 64. You can right-click on a nest and choose the report option as well. That will then generate a report for that nest. And this is actually quite a nice report. Very nice layout. We have our source parts, so it shows us the parts we chose to nest with all of their properties. We can hide that. We can see the inventory, so the inventory that was selected. And for some reason, the inventory is cut off here. I think there should be more lines listed here. but we have the inventory. Sorry, I'm only looking at nest 64, so it's only showing the one sheet type that was used. My apologies there. So we have that sheet that was used. The quantity was set to infinity, so it just puts 999 in here. And so we know, okay, that's the material we used. If we go to the sheet details, we can see sheet 1's layout. And then the properties regarding that sheet, we saw a nesting efficiency of 83% on that sheet. And we can then see for that sheet the part summary. And here's the nice thing, we can look at the back component. We had 2 of them on that sheet, and the weighted nested cost, or the cost of that component when it's nested, was essentially 67% of the sheet. If the sheet cost us R1, it's going to cost us 67 cents for those 2 components. The material cost itself was 58%, so that's not including any wastage. And so we can continue down the sheet 2 with its properties, and the sheets section, if I just go ahead and hide the sheet details, the sheet section will then show us the overall usage of sheet 1 and sheet 2. So we've got a lot of cost details that we can pull out of here as well. Remnant efficiencies, various costs that can be pulled from this. And then part summary. This gives you a summary of all of the components and their related information. And just in case anything was excluded because it didn't fit, there is a excluded parts section as well. This can be saved. This can be saved out as an HTML or a PDF. I see something like this, and my hopes for the future would be that they work a way of exporting this as a Excel spreadsheet, or a format that could be imported into an ERP system, because that would make life so much nicer for costing. But at the moment, it is a preview function, so we can't expect more than that. This is already a lot that they've brought into the report side of it. So I'm looking, I have just under 10 minutes left. So I am going to, I've done the demo already, so I'm going to close off with a summary. That gives us a few minutes for questions as well. Yeah, so to summarize, why would you want to do nesting? It will save time. It'll allow you to save time through automation. Like I said, playing Tetris. It's going to save that time. It's going to optimize your material usage within your process, and it will allow you to predict material usage as well for ordering. You know, you have a job coming up, you can do the nesting, and you know, okay, I need to order 10 sheets of that material. And it'll also allow you to predict individual part and overall material costs. That will help with your cash flow. It also helps you to quote the customer. In summary as well, we can nest any components. So it'll even work for cabinetry doors, as I showed in that one slide as well. And something I didn't show the workflow on, but you can create a manufacturing model, which you can then pass further down the chain in Fusion and create your machining from that. You can either do your laser, plasma, water cutting from that machining model, or from that manufacturing model, or even do your full 3-axis machining of that of those nested components. So that'll bring me to a close. On my side of the presentation, I'll open up to any questions. Feel free to put them through in the chat. I will also unmute all participants. So you might still be muted on your side, but you can unmute and ask questions as well if you have any questions. Okay, thank you, gents. I see no one has any questions. They're saying that everyone's saying that they're good. So thank you so much for your attendance and listening in on the webinar today. I hope that you've gained some valuable information with what is in Fusion at the moment as far as preview functionality, and showing some good promise for the future when it comes to nesting directly inside of Fusion 360. Once again, this webinar was recorded. It will be posted up on our YouTube channel as well. So if you want to come back and just refresh on anything, it will be up on YouTube. My email address was on the first slide, but we do have offices in Joburg, Cape Town, Port Elizabeth, and Durban. I am based in Port Elizabeth, so if you need to get hold of me, that would be the number to call and someone can put you through. Alternatively, contact your closest branch and they'll be able to assist you or point you in the right direction. Thank you once again for attendance, and enjoy the rest of your day.